Real quick where we left off last time. We talked about using JPA or Java Persistence API as a technique for implementing a very popular design pattern called the object relational mapping design pattern. It's a strategy that it's used for allowing us to think about interacting with the relational database with objects and classes and instances as opposed to SQL and records and tables. We added JPA and configured it to point to a local database. For the you'll need to point it to your own database, either whether it's running locally on your machine, your local host, whatnot, or if you're hosting this on Heroku or AWS, they will provide you with a URL to your database, and you'll use that here instead. You also provided here configuration outside of the source code. So this is a configuration file that allows you to configure the behavior of the database outside of the source code, so you don't have to recompile. You can point to a different database vendor, right, and configure everything outside of the source code. Also, the authentication, usernames and password, and whether you wanted to JPA to manage the schema for you. That would create the schema for you, would redefine the schema, the data types, name of the tables, name of the fields, and whatnot. We also configure our project to download the necessary libraries, such as the JPA library and the MySQL connector. We model a couple of things here for courses, modules, and whatnot, and implemented a couple of one-to-many relationships. We created several classes, and we created a couple of repositories, and we saw how repositories allowed us to use a couple of out-of-the-box, very generic functions that allowed us to retrieve all records, retrieve a particular record, create records, update records, all from within the repository. And we used the generic find all to be able to retrieve all the records. We had to cast it to the data type we wanted to use. We also saw that we could retrieve individual records as well, right, and use the get to unwrap the wrapper, the optional wrapper that has our object in there, and then cast it to the right data type. We also implemented a couple of custom queries using the at query, right, and this allowed us to implement our own implementations of retrieving data from the database, as opposed to, instead of using the out-of-the-box generic implementations on find all, find by ID, we could implement our own queries. We saw that there were two flavors of that: the native query, where we can put the literal string that we want to use to a database, and there was this higher-level query that allowed us to think about it in terms of classes and properties inside of those classes, as opposed to tables and fields within those tables, right? Right, we use those custom queries. We also saw how to save in the database using .save, and .save, we saw that it was a function that was smart to that it would know whether we needed to insert if this was a brand new record, or if it had to update if this was instead an already existing record. Here we are instantiating a brand new object. So this presumably was not already in the database. So this .save creates an insert, whereas if you retrieve a particular and then you save, it would be an update. We also looked at delete. We also took a look at inheritance and how you can configure different types of inheritance. That the default implementation is to bring together all the fields in the base class and all the derived classes all into one single table, right? We call this the strategy, the single table strategy, right? And we saw that we also mentioned that this was the fastest performing implementation, since it avoided the need for joining multiple tables, right, in the other strategies. We looked at let's see. We also looked at modeling one-to-many. I think the example that we used was courses and modules. We used faculty and courses, where there were a one on side and a many side. On the one side, you annotated using one-to-many, and on the many side, you annotated with many-to-one. right? And the way it was implemented is that on the one-to-many, you had a list of the children, and on the child, you have a reference back to your parent. So here's an example where the course has a many-to-one. The child course has a many-to-one with authors, meaning this course can be authored this course can be authored by this particular faculty. And on the other side, the faculty can have a list of all the authored courses as a list of courses. These are all the courses that this particular faculty has authored. And you just had to map it saying, who was referring to who. Where the course was referring back to the author using this field, you had to configure it using the map by attribute. And we saw the implementation of courses implementing that references as a foreign key back to the parent faculty. Okay. All right. I think this is where we left off. Let's take a look at the source code that we worked on last time.